Alright, so let's talk about how to graph piecewise functions. So first of all, the idea of piecewise functions is a function made up of separate functions. Okay? The separate functions are called subfunctions. So for this example here, uh, y equals negative x plus 1, this is the first subfunction. Okay? Now it's very important to pay attention to the domain that is given for the subfunction. So for this function, right, they're saying that x has to be less than negative 1. Okay, so now let's graph this function right here, which we know is going to just be a straight line, right, because it's a linear equation. So the y-intercept is 1, your slope, negative 1 over 1. So you'd go down 1 over 1, down 1 over 1. Now if you want to find some points to the left of the y-axis, you would go up 1 to the left 1, right? Up 1 to the left 1 to find some points. Now, we have to pay attention to our domain. If our domain says x is less than negative 1, right? So typically if you graph this line, you would have a line that looks like this. But since our domain is x is less than negative 1, that means that at negative 1 on the x-axis, we don't want to show any part of this graph after negative 1 on the x-axis. So that means we need to erase all of these values right here. Right, so our graph is going to look basically something like this for this subfunction. Okay, now let's take a look at the next subfunction. Right, so we have y is equal to 2 to the x power minus 2. Oops, yeah, minus 2. And then we have our domain, which is between negative 1 and 3 inclusive. So the first thing you want to do is you want to plug in this negative 1 value into the function so that we can find out exactly where this point would be, right? So I'm going to plug in negative 1 into the function for x. So we have 2 to the negative 1 power minus 2. So that gives us 1/2 minus 2. So then we're going to end up with negative 1.5, right? So what this means is when the x value is negative 1, we know the y value will be negative, right, 1/2. So we can plot a point here. Now you notice that they have the equal to part here. So that means that when x is negative 1, y is negative 1.5. So negative 1.5 is right here. And then we can make a colored in bubble because we're including the value at x equals negative 1. Okay. Now we're going to do the same thing when x equals 3 right here. So I'm going to take 3, plug it into the function. So we have y is equal to 2 to the third power minus 2. So 2 to the third power is 8 minus 2. So that gives us 6. So that means that when x is 3, we know the y value is 6. So when x is 3, we're going to go up to 6 right here. Now, it's inclusive, so I colored in the bubble. Now you have to think, so our function here, 2 to the x power minus 2, we know that's an exponential function, right? So since it's an exponential function, we're going to make a kind of an exponential curve going up, and it would look something like this. Alright, so let's take a look at our last subfunction. So we have y is equal to x minus 3, right? And the domain is x is greater than 3. So we know when we graph this, we're just going to have another straight line. So our y-intercept is negative 3. Our slope is 1 over 1, right? So that means you go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Now, you have to pay attention to the domain. So the domain says x is greater than 3, right? So that means that we don't want to show any part of this graph, right? So if we graph this, we would get a straight line like this, right? But we only want to show, right, x is greater than 3. So we don't want to show anything before 3 on the x-axis. So I would erase all these values over here. And then also at x equals 3, we know we don't count that point. So it should be an open circle right here. Okay? Alright, so let's take a look at another example here. So let's take a look at the first subfunction right here. So we have y is equal to x. Okay, so now we just have a linear equation here. So our y-intercept is 0, our slope is 1 over 1, so we go up 1 over 1, up 1 over 1, up 1 over 1. Alright, we can find some points down here. And our domain is x is less than -4, right? So that means that if we were to graph this, right, we only want to show the part of the graph, right, that is where x is -4 and before that, right? So anything after -4, we don't want to show it. So all this part here, we're not going to show. And also at x equals -4, it's not inclusive, so we should have an open bubble here. Okay. Our second subfunction, right, y is equal to 2 to the x minus 3. Well, we need to plug in these values to find out where the coordinates are going to be at, right? So I'm going to have 2 to the -4 power. So if I simplify that, that's 1 over 2 to the 4th. So that gives me 1 over 16. Minus 3, right? So if you get common denominator here, that's going to give me 1 over 16 minus, if I get common denominator, that's 48 over 16. So I end up with -47 over 16. So basically what this means is when the x value is -4, my y value will be, alright, so I'm going to basically end up with -2 and 15 over 16. Okay. So if I plot this, I have x equals -4, so I'm almost going to be at -3, right? And then I'm going to include that value, so see, we're going to be real close to -3. So when x is -4, we're almost at -3, okay? And then I'm also going to plug in the 2 now into the function. So I have 2 to the second power minus 3. 2 to the second power is 4 minus 3, so I get 1. So I know when x is 2, my y value is 1. So I'll make a point there. 2, I'm at 1, right? And I need to have an open bubble here because it's not inclusive. So let me make an open bubble here. Now we have an exponential function, 2 to the x power, so it's going to have our exponential graph right here. Okay. And the last subfunction, so we have 3 plus, right, square root x, right, so y is equal to 3 plus square root x, and our domain is x is greater than or equal to 2. So the first thing I need to do is I want to plug in 2 into the square root here. So we get 3 plus square root 2. Square root 2, if you put in your calculator, it's approximately 1.41, I believe. So we're going to end up with 4.41. So what that means is when x is 2, I know the y value would be 4.41. So when x is 2, I know the y value would be 4.41, so almost at 4.5. So about right here. And our radical function, we know it's just going to look something like this. Right? Alright, let's take a look at this example here. So this one's a little bit tricky with the second subfunction, and you guys will see why. So the first subfunction, right, so we have y is equal to x plus 3 squared, right, and we have our domain, x is less than -2. Alright, so let's think about what x plus 3 squared looks like. That's basically just a parabola that shifted 3 units to the left, right? So a parabola shifted 3 units to the left, so it would typically look something like this, right? Now, our domain is x is less than -2. So let's plug -2 into here, right? So we have -2 plus 3 squared. So basically we're going to end up with +1, right? So that means when x is -2, we're going to end up with +1 as our y value, right? So what that means is when x is -2 here, we know that the point will be at +1, right? Now, we're not including the value at -2, so we have to have an open circle here. So basically we have a parabola on the right side, it would just go up to right there, and on the left side, it would basically just keep on going up forever on the left side of the parabola, kind of like this. Okay? Now the second subfunction, this one's a little bit tricky, right? So we have y is equal to -3 plus square root x. Now our domain is from -2, all right, to 4. But here's the tricky part. If we plug in -2 into here, right? So you have the square root here. If you plug in -2, what happens is you can have an imaginary value, right? So since you have an imaginary value when x is -2, if it's imaginary, that means we're not going to see any part of the graph. The graph is going to be invisible at that point, okay? And if we plug in -1, it's still negative inside the radical. So the graph would still be imaginary, right, at that point. So the first x value where we're going to actually, right, not have a negative inside the radical is when x is 0, right? So when x is finally 0, we're going to end up with -3 as our answer. So we know when x is 0, the y is -3. So that's the first, our x value, where we'll actually see, right, the graph of this function. So at 0 and -3, right, we're going to have a point here. We could color it in, right, because it's inclusive. Now, I'm going to plug in the 4 now. So the 4 should be fine. So y is equal to -3 plus square root 4, which is 2. So -3 plus 2, so we end up with -1. So we know when y is, when x is 4, the y will be -1, right? And we need an open bubble here, right? Because it's not inclusive. And then we have a square root graph, right? So we know the square root graph kind of just goes like this, okay? And then the last function is an easy one. We have y is equal to x, so that one's easy to graph. So we basically start at 0, 0, and then our slope is 1, so we go up 1 over 1, up 1 over 1, up 1 over 1, right? And then we just need to look at the domain. The domain says x is greater than or equal to 4. So we're only going to show the part of the graph from when x is 4 and after. So at x equals 4, it's inclusive, so we can have a colored in bubble. Then anything after that, so that's what that graph would look like right there. Okay.